Imagine standing at the edge of a cosmic waterfall, where the sun's grip on its own particles weakens, and they plunge into the vastness of space, a point of no return. This is the Alphen surface, a boundary as dynamic as it is mysterious, and scientists have just mapped it in unprecedented detail for the very first time. For years, researchers could only speculate about this shifting frontier, where the solar wind breaks free from the sun's magnetic embrace. But now, thanks to groundbreaking data from NASA's Parker Solar Probe and other spacecraft, we have a clear picture of how this boundary behaves, and it's more dramatic than anyone imagined. But here's where it gets controversial. Does this new understanding challenge our existing models of solar physics, or does it simply refine them? The maps reveal that the Alphen surface isn't just a static line in the sand. It expands, roughens, and becomes more jagged as the sun ramps up its activity during periods marked by sunspots and solar flares. This transformation is like watching a calm river turn into a raging torrent, but on a cosmic scale. And this is the part most people miss. The boundary's behavior isn't just a curiosity. It's key to solving some of the sun's most enduring mysteries. Lead researcher Sam Badman, an astrophysicist at the Center for Astrophysics Harvard and Smithsonian, explains, "Before, we were navigating in the dark, estimating the sun's boundary from afar. Now, we have a precise map to guide us as we explore this critical region." By combining close-up measurements from the Parker Solar Probe with data from the European Space Agency's Solar Orbiter and NASA's WIND mission, the team has confirmed what was once only theory. The Alphen surface shifts dramatically with the sun's 11-year activity cycle, expanding during solar maximum and retreating during quieter periods. But why does this matter beyond the realm of astrophysics? Pinpointing this boundary is crucial for improving space weather forecasts, which protect astronauts, satellites, and even Earth's power grids from the sun's unpredictable outbursts. It's also central to understanding why the sun's corona, its outer atmosphere, gets hotter as it moves farther from the solar surface, a phenomenon that has baffled scientists for decades. The Parker Solar Probe's daring dives into the sun's atmosphere have been instrumental in this discovery. Using its solar wind electrons alphas and protons, SWEAP, instrument, the probe directly sampled the region beneath the Alphen surface, confirming the map's accuracy. This work proves that Parker is venturing deeper than ever into the birthplace of the solar wind, says Michael Stevens, an astronomer at the CFA and SWEAP's principal investigator. As the probe continues its mission, it will observe how the Alphen surface evolves over a complete solar cycle, from maximum to minimum activity. This long-term view promises to unlock even more secrets about the sun's behavior. But here's a thought-provoking question. Could this boundary's dynamics hold clues to predicting extreme solar events, potentially saving billions in infrastructure and even lives? While the new maps are a monumental achievement, they also highlight how much we still don't know. There are fascinating physics questions about the sun's corona that remain unanswered, Stevens notes. As scientists continue to explore this cosmic frontier, one thing is clear. The Alphen surface is more than just a boundary. It's a window into the sun's soul, and its secrets are only beginning to unfold. What do you think? Does this discovery bring us closer to unraveling the sun's mysteries, or does it reveal just how much we still have to learn? Share your thoughts in the comments below.